Unit 6.1 is where we're going to start talking about the periodic table. So we've talked about this previously, but the periodic table is what we use to organize all of our elements. And what's really cool about the periodic table is that you can tell the properties and you can tell what kind of element you have based on its location on the periodic table. That's why it has this structure, and that's why it kind of looks like, I think it looks like a castle. This is an early version of the periodic table from 1869. And you can see over here, so here it's written out in handwriting and here it's just typed. It's the same thing though. But you can see that there's the elements. There's barium, boron, carbon, nitrogen, oxygen, fluorine, sodium. All right, and they were organized by weight. But there were some discrepancies. So there was a lot of debate about what they should organize the periodic table by. Because argon and potassium, if you look at them, they should be split if we go by weight. So there were other versions too. Some of them were even cylindrical. People had all different crazy sorts of ways of organizing the elements as they started to find them. But Dmitri Mendeleev, so he came along, he was born in 1834 and died in 1907, so the late 1800s he was doing his work. And he was known for predicting the properties of unknown elements. So that was his important contribution to the periodic table. He was able to organize the elements in such a way that he knew that there were more elements that were going to be found, because they hadn't all been found at that point. There were only a couple of them, but he knew that there were some slots where some elements would fit in, and he could actually predict like how those elements would react, like what their melting point would be, how heavy they would be, things like that. And he organized elements in groups, which are columns, that have similar properties. Lavoisier was another chemist who helped out during this time. In 1913, this other guy came along, Henry Moseley. So Henry Moseley used X-rays. So he would X-ray samples of elements, and he was able to do this, and he noticed that there was a number associated with each element, and that was actually the first time that somebody was able to prove the atomic number. So if you guys remember, the atomic number is the same as the number of protons, right? If you don't remember anything else about this course, please remember that. The atomic number is the same as the number of protons in the nucleus. And this was really important. So when he actually then went back and looked at Mendeleev's table, he noticed that Mendeleev had organized everything by atomic number. Even though they didn't know what it was at the time, Mendeleev was able to organize everything by the atomic number. And that is the main thing that is used to organize the periodic table today. So the periodic table, so why is it called periodic? Okay, so what does even periodicity mean? So periodicity is just the quality or character of being periodic. So it's a tendency to recur at intervals or over either a certain time, or it doesn't have to be time. It could be over a certain distance. Anything that's periodic means that it repeats. So what are some things that are periodic? Well, you can see down here on the bottom left, here we have the seasons. So the seasons, they repeat once a year. So those are periodic. Going back to school, right? That's something that's periodic. We do that every fall. If you look at a racetrack, so the cars go around the track periodically. And the last example here are phases of the moon. So the moon repeats its phases every 28 days. So these are all some things that are periodic. So the periodicity of the periodic table is that the properties of the group, and time, lastly time, of course, is periodic. We have 24 hours in the day and they repeat every day, right? So the table is periodic because the properties repeat every group there. So when you go down a row, the properties in each group will be the same. So let's look at, if you look at hydrogen at the very top, has similar properties to lithium.